In the last class we learnt about the bond parameters. They have a 6 bond parameters are there, that is bond length, covalent radius, van der Waals radius, bond angle, bond enthalpy and bond order. In that, bond length is the distance between the nuclei of two bonded atoms in a molecule. It means the distance between the two atoms. This is the distance. This should be called as a bond length. Next is covalent radius. Covalent radius means 1/2 of the distance between the nuclei and two covalently bonded atoms of the same element in the molecule. Here they are considering the same element. They are considering the same element. In that, this distance is called as a bond length. The half of this distance is called as a covalent radius. And third one is van der Waals radius. It is defined as 1/2 of the distance between the nuclei of two adjacent identical atoms to two neighboring molecules of an element. Here there are two molecules are there. In that, the adjacent identical atoms, they are saying adjacent identical atoms distance. In that, half of the distance is called as a van der Waals radius, and the bond angle is the geometrical angle between the two adjacent bond. Here this should be called as a bond angle. Next, fifth one is bond enthalpy. It means there some amount of energy is required to break the 1 mole of bonds of a particular type between the two atoms. That two atoms should be present in the gaseous state. Okay, next, last is bond order. Bond order is given by the number of bonds present between the two atoms in a molecule. It means the how many bonds are present between only two atoms. Okay, not all the atoms present in the molecule, only two atoms. That should be called as a bond order. Here for hydrogen molecule it has only one. For oxygen there are two. For nitrogen there are three. These are all about the bond parameters. And next we move on to the polarity of bonds. Next is polarity of bonds. In that, we have to know about the what is dipole moment. Before going to the know about the what is dipole moment, we have to know about what is polarity. Polarity means they have both positive and negative charges. Polarity of the bond, it means the bond means they needed two electrons. It might be present in the same molecule or it might be in the different molecules. Okay, in that, the polarity of bonds means that bond it has both the positive and the negative charges it contains. That should be called as a polarity of bonds. Here for example, for hydrogen molecules, here positive, both hydrogen has a positive charges. But when we consider the HCl, here hydrogen carries a positive charge, chlorine carries a negative charge. This should be called as a polarity. They have a polarity. Okay, it means they have a positive and a negative charges. They have a electrical dipole also by applying a electric field. That should be called as a polarity bond. And next we move on to the dipole moment. Dipole moment is defined as the product of electric charges, and the distance between the positive and a negative centers in a polar molecule. in a polar molecule. This is called it as a dipole moment. It means it has the product of electric charges. It means they have some, here they are taking a polar molecule. Polar molecule, in that you have to know about that the bond should be formed between the oppositely charged ions. Okay, then we are considered HCl. This is called a polar molecule. We are considering H2 molecule. This is have the same charge. This should be called it as non-polar. Okay, it is positive and the negative. This product of electric charges and the distance between the positive and negative centers. This distance between the positive and the negative centers, that should be called it as a dipole moment. Did you get it? It means it is defined as the product of electric charges and the distance between the positive and negative centers in a polar molecule. Polar means it has a positive and a negative charges. It means the bond should be formed by the opposite charges. Non-polar means they have a same charges. Okay, this product, positive and negative product, and that distance between the positive and the negative centers is called it as a dipole moment. And this dipole moment is measured by, it means unit is dB. That should be written in the capital D. Okay, how to calculate a dipole moment? They have a formula. Dipole moment is equal to mu. Dipole moment is mu is equal to Q into D. Q is the charge, D is the distance. Q is the charge and D is the distance between the charges. Distance between the charges. Okay, 1 dB is equal to 3.3338 into 10 to the power of minus 30 coulomb meter. Okay, this is about the dipole moment. I will show the example also. We have to know about that. It is defined as the product of electric charges and the distance between the positive and negative centers in a polar molecule. The SI unit is D. How to calculate a dipole moment means there is a one formula. Mu is equal to Q into D. Q is equal to charge, D is the distance between the charges, and 1 dB is equal to 3.3338 into 10 to the power of minus 30 coulomb meter. And next we go on to the examples. Here we are taking a water molecule H2O. The structure is HH. Here you have to consider hydrogen is the positive charge, oxygen is the negative charge. This is the dipole moment should be shown like this. Okay, the dipole moment should be shown like this by showing the arrow mark. Here how much dipole moment is there? 1.84 dB. Okay, in that, here the arrow should be pointed towards the arrow pointing towards the electronegative atom. Electronegative atom. Okay, here that should be called it as a dipole moment. In that you have to know about that the arrow should be goes on towards oxygen. Compared to hydrogen and oxygen, more electronegative atom is oxygen. You have to know about that from left to right in the periodic table. From left to right, electronegativity increases. Electronegativity increases, so that's why oxygen is the most electronegative atom. Then the arrow mark should be pointing towards the oxygen atom. The dipole moment is 1.84 dB. And other example also carbon dioxide. Okay, in that it has a linear shape. Okay, you have to know about that. In the periodic table, carbon comes first and then oxygen. Okay, so compared to carbon, oxygen has the more electronegative. Okay, in that the arrow mark should be goes through the most electronegative atom. It means goes through the oxygen atom. Here the arrow mark should be pointing towards more electronegative atom. Comparing carbon and oxygen, oxygen is the most electronegative atom, so that's why this arrow mark should be goes through the oxygen, pointing towards the oxygen atom. Then the dipole moment is 0. Why here the dipole moment is 0? Because carbon dioxide is a linear in shape, because CO2 is in linear, hence the dipole moment in both the directions are equal. Both the directions are equal and opposite. So net dipole moment is 0. Did you get it? Okay, here carbon dioxide dipole moment is a 0 because the carbon dioxide gas is linear in shape. In both the side, the oxygen atom should equally possesses the dipole moment and are equal and opposite, so net dipole moment will be 0. Okay, in the BF3 also you have to consider like BF3, and like this molecule is also called it as a non-polar molecule. They don't have a net dipole moment. It means they don't have a net dipole moment. The dipole moment is 0. That molecule is also called it as a non-polar molecule. Here also BF3, here F. Compared to boron, fluorine is the more electronegative atom. Then arrow mark should be goes towards the fluorine atom. Here also the dipole moment is 0 because they are equally shares the electrons from the boron atom. So that's why the dipole moment, the net dipole moment is 0. Okay, this is all about the dipole moment. And next we move on to the polar molecule. I already told that what is polar molecule. In the polar molecule they have a permanent dipole moment, and non-polar molecule, it means they do not have net dipole moment. This is the example for this is H2O and ammonia, and this will be the carbon dioxide BF3. Also we are taking which molecule does not have a dipole moment, that should be called it as also a non-polar molecule. Which molecule have a dipole moment, they call it as a polar molecule. Okay, this is all about the polar and the non-polar molecule. Next we move on to the polarity. How the polarity recognize the how much ionic character should be present in the bond. Polarity, how much should explain the how much percentage of ionic character. Polarity, it should explain the, it explains the how much ionic and covalent character also. Covalent character present in the molecule. Okay, mainly polarity explain. Okay, in that mainly the bond polarity mainly explains ionic character. In that the ionic character is less, the covalent character should be more. Okay, here how to the ionic character explain? It means greater the difference in the electronegativity between the atoms greater the polarity and the greater the polarity and higher the ionic character. Okay, did you get it? It means if greater the difference in electronegativity values between the atoms, here I am giving the example HF, HCl, HBr, HI. Okay, the difference between the electronegativity here in compared to hydrogen and fluorine has the more electronegative atom, and here hydrogen to chlorine has the more electronegative atom. Comparably hydrogen and bromine has a more electronegative atom, and here also iodine more electronegative atom with compared to hydrogen. But when we are comparing with fluorine, chlorine, bromine, iodine, fluorine has the more electronegative differences is there. Okay, more electronegative atom, so HF has the more electronegative differences, and hence it has the polarity, high polarity. HF has the more electronegativity differences, so it has greater polarity and high ionic character. Did you get it? And here the polarity should be what? Decreases. Polarity decreases, then the ionic character also decreases. You have to observe this. Greater the difference in electronegativity between the atoms, greater the polarity and higher the ionic character. In that HF has the more electronegative differences compared to these, in that the polarity decreases. So HF has more electronegativity, then it has a high polarity and high ionic character. Okay, because why HF has the more electronegativity difference means compared to chlorine, bromine, iodine, fluorine has a more electronegative atom. Here down the group in the periodic table, the electronegativity decreases. So that's why fluorine has the more electronegative atom. Did you get it? If polarity in the bond greater the difference in the electronegativity between the atoms, greater the polarity and higher the ionic character. In that, HF is what? HF is greater than HCl. HCl is greater than HBr. HBr is greater than HI. In that, HI has the less ionic character because it is a less electronegative atom. Next is, if ionic character is 0, ionic character is 0, and it means percentage of ionic character is 0, then difference in electronegativity atoms, difference in electronegativity, negativity is 0, then Xa minus Xb is equal to 0. It means Xa and Xb means the two atoms, there should be electron differences, electronegativity differences. Okay, in that bond is covalent bond. That bond is show the covalent character. Covalent character. Did you get it? It means if ionic character is absent, it means is equal to 0. Difference of electronegativity is 0. That Xa minus Xb is equal to 0. Then that bond shows the covalent character. Okay. If Xa minus Xb is equal to 50%, 50, it means almost 1.7, 50%, almost 1.7, then the bond has 50% covalent character and 50% ionic character. Did you get it? If this difference is 0, the bond will show the covalent character. If the difference is 50%, almost 1.7, then the bond has 50% covalent character and 50% ionic character. Next, if Xa minus Xb is less than 1.7, then the bond has more covalent character and less ionic character. Okay. Next, if Xa minus Xb is greater than 1.7, then the bond is more ionic character and less covalent character. Okay. There will be one formula is there to calculate the percentage of ionic character by Haney and Smith. Okay. The formula is percentage of ionic character is equal to 0.16 Xa minus Xb plus 0.035 Xa minus Xb whole square into 100%. Okay. When we multiplying this 100, we getting here A minus B is equal to, when we multiplying 100, we getting 16 into XA minus XB plus 3.5 into XA minus XB whole square percentage. Okay, here XA minus XB means difference in electronegativity between the A and B atoms. Okay, these are all about the ionic bonding. In that we have to know about the ionic character. Here ionic character is 0, difference of electronegativity is 0, XA minus XB is equal to 0. The bond character is shows covalent character. If XA minus XB is equal to 50, it means it nearly 1.7. Then the bond has 50% covalent character and 50% ionic character. If XA minus XB is less than 1.7, then the bond has more covalent character. Okay, if greater than 1.7, the bond has more ionic character. There is one formula by Haney and Smith shown how to calculate the percentage of ionic character, that is 0.16 into XA minus XB plus 0.035 into XA minus XB whole square into 100%. That should be multiplied by 100. We getting this formula. This XA minus XB is the difference in electronegativity between atoms of A and B. These are all about the ionic bonding. In the next classes we learnt about the covalent bond. Thank you one and all.